Welcome to STAAD Foundation Advanced lecture series by Civil Thinking, and this is our first class on STAAD Foundation Advanced. Now before I move on, I suggest you to please watch the video lectures on STAAD Foundation Advanced one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now before I move on, I would like to tell you that we are going to learn about the STAAD Foundation Advanced, but the Connect version. Okay, Connect Edition. Connect Edition is the latest edition. Okay, it have more advanced features and capabilities, and it is also fast than the previous editions of STAAD Foundation. So this is our first class, and in this class we are going to go a little bit inside the foundation engineering, because in the STAAD Foundation Advanced what we do, we design the foundations, right? So we need to know a little bit about foundation engineering. Okay, so let us begin. Now let us consider a building, for example a superstructure. Okay, let us say this is a building. Okay, we call whatever is out, above the ground level. For example, this is our ground level. Okay, whatever is above the ground level we call it as superstructure, and whatever is below the ground level we call it as substructure. Okay, and in the substructure we have foundation. Okay, now what we do, below the ground level we construct a foundation, right? This is our foundation, and on the foundation we construct our superstructure. Okay, now the superstructure, there are loads because of superstructure, right? Loads from the superstructure. Okay, they are supported by the foundation, and the foundation disperses these loads, transmits these loads to the subsoil, right? This is our subsoil, right? So the loads come from superstructure. Okay, they are resisted by the foundation, and the foundation then what it does, it transmits these loads to the subsoil safely. Okay, so uh, the loads from the superstructure are transmitted by the foundation to the subsoil. Okay, so if I write about this, I can write foundation helps safely. Okay, I will use the word safely, transmit the loads from superstructure to the soil. Okay, so what does it do? It transmits these loads to the subsoil, but safely. Okay, so what do we mean by safely? Safely means the transmission of the loads from the superstructure to the subsoil is such that there is no failure. Okay, no failure of the foundation, and there is no failure of the subsoil. Okay, safely means no failure of subsoil and foundation. Okay, so in the foundation engineering we usually study the strength of the foundation and the strength of the subsoil. Okay, so there are two main important things in the in the foundation engineering, that is subsoil and the foundation. Okay, these are two things which we are concerned in the foundation engineering. Okay, and we design foundation such that the foundation itself is safe, and also the subsoil is also safe from the loads of the foundation. Okay, because the foundation applies loads on the subsoil. Okay, so there is a chance, there is a risk of failure of the subsoil, and also because the loads are acting on the the foundation, so there is itself a risk of failure of foundation itself. Okay, so we have two things. Okay, so we design in the foundation in STAAD Foundation Advanced. Okay, so we will see some aspects of this design here. Okay, so that we can apply them in the STAAD Foundation Advanced Connect Edition. Okay, so when it comes to subsoil, there are a few things, a few critical things. So in the subsoil, what we have there can be settlements. Okay, there can be settlements in the subsoil, or there is other thing about subsoil. It is bearing capacity. Okay, bearing capacity of subsoil, settlements of the subsoil. Okay, so these are the two things in the subsoil. Okay, so what are settlements? So we have a foundation here. Let me denote the foundation with F. Okay, F for foundation, and let us denote the subsoil with S dot S. Okay, so this is our subsoil. Okay, so when a load is applied on the foundation, where does this load come from? The load comes from the superstructure. Okay, so the load will try what will it will does, it will cause the settlement of the foundation. What does it mean? Settlement means it will sink inside the earth. Okay, so it will displace below. So the foundation will be now like this. Okay, so it has sink. Okay, it sank inside the subsoil by what? Settlement. Okay, so this is our settlement. Okay, now in the settlement we have two kinds of settlements. We have immediate settlement, and we also have what we call them as differential settlement. Okay, differential settlement. Now immediate settlement is when the settlement in the subsoil occurs immediately after the construction of the foundation. Okay, it occurs because of the compression of the soil and because of the consolidation of the soil. Okay, and differential settlement is when there is unequal settlement. Okay, so this is our foundation, this is our subsoil. For example, this part of the subsoil we have more for example settlement, and this part we have less settlement. Okay, so because of the difference in the settlements, we call it as differential settlement. Okay, and keep in mind the differential settlement is more dangerous than the immediate settlement. Okay, because it might cause the tilting of the foundation, or even it will cause the failure of the foundation. Okay, so differential settlement and immediate settlement, so these are all of these settlements, they should be within the permissible limit. Okay, permissible limit. Okay, why permissible limit? Because it is not possible to avoid the settlement 100%. Okay, we cannot avoid the settlement 100%, but we can keep them in the permissible limit. Okay, so this is about settlement. And about the bearing capacity, now this the foundation exerts a pressure on the subsoil, right? Pressure, right? The pressure is exerted by the foundation to the subsoil. Okay, so the bearing capacity of subsoil should be enough to resist this pressure. Okay, so what is bearing capacity? Bearing capacity is what? Bearing capacity is the maximum pressure the subsoil can withstand. Okay, so bearing capacity of subsoil should be what? It should be greater than the applied pressure. Okay, so we have to design the foundation such that there is what the settlement is in the permissible range, and also the pressure should not be more than the bearing capacity of the soil, otherwise that would cause the failure of the subsoil, right? So these are two things in the subsoil. And then when it comes to foundation, let me write it here. So in the foundation, we can have possible, a few types of failures. For example, we can have overturning. Okay, we can also have tilting. Okay, we can have failure of foundation because of the lateral loads. Okay, and more, let me first discuss these things. Now, what is overturning? Let me erase this. So the overturning is what, the we have a load on the foundation because of the superstructure, right? And there will be a reaction, right? Reaction, the reaction from the subsoil. Okay, now if there is eccentricity, right, you can see there is some eccentricity. Because of the eccentricity, a moment will be generated, right? This moment will try to what, to tilt, right? Tilt, and if it is too much, it can even cause overturning, right? This is foundation. Okay, so if it is the moment is more, okay, the moment will try to tilt the foundation. Okay, tilt the foundation, and if it is too much, it will even topple or overturn the foundation. Okay, so we have to make sure we have to design the foundation such that there is some the resisting movements to counter these the overturning or tilting movements. Okay, similarly we have these lateral loads. Lateral loads are here. Okay, so the lateral loads, they might cause failure in the foundation. Okay, they might slide the foundation to the left or right, or they will they can compress it and cause the failure. Okay, so we have to make sure the foundation can withstand these lateral loads. Okay, so our foundation should withstand. Okay, okay, and keep in mind, it is not possible to 100% avoid the overturning or the tilting. There will be some degree of tilting. Okay, and lateral displacement. Okay, so what we have to do, as a foundation engineer, maximum we can do is we can make sure they are in the permissible limits. Okay, so if they are in the permissible limits, it means they are not serious. Okay, they won't cause a serious threat. Okay, so let us move on to other so we have uplift forces. Okay, they are not common. Okay, if they exist. Okay, so we have to make sure the foundation will withstand these the uplift forces. Okay, so the uplift forces are here. These are the uplift forces. Okay, and they will try to uplift the foundation. Okay, so we have to make sure our foundation is foundation can withstand these uplift. Okay, and there will be no failure in the foundation because of the uplift forces. Okay, now there is also there are some kind of soils in the, for example, we have expansive soils. Okay, expansive soils, one of the famous example is what, black cotton soil, right? Black cotton soil. Now what are these expansive soils? They basically they are very reactive to the change in the water level. So if there is more water, okay, they will absorb it, and they will, for example, if this volume was this, they will expand. Okay, they will expand. Okay, so they will exert uplift forces. Okay, and if the water levels, okay, they will shrink. Okay, if the original volume was this, they will shrink. Okay, maybe they will reduced to only this. Okay, so then there is chances of what, settlement of the foundation. Okay, so if in case you are designing a foundation on expensive soils, you have to make sure the foundation can withstand the change in volume of the expensive soils. Okay, then what we have, then we have, now this was all about what, this was all about foundation and subsoil, right? We see the settlements in the subsoil, we see the bearing capacity of the subsoil, so they are all geotechnical things, right? So this is all, they are all geotechnical things. Okay, now we will talk about the interaction of superstructure load and the foundation now. Okay, now we are concerned with this now. Okay, initially we talk about the subsoil. Okay, now we will not talk about this, now we will talk about this. Okay, this surface, we were first discussing about this contact surface between what, contact surface between the foundation and subsoil. Okay, now we will talk about the contact surface between, this is the contact surface between what, superstructure and the foundation. Okay, now we will talk about this now. So let me first write, there can be failure of the foundation because of this applied load. Okay, this applied load from what, it is from superstructure. Superstructure, so let me write this, failure due to superstructure loads. Okay, so there can be multiple possibilities of the failure. So let me show it here. If this is our foundation and this is our load, superstructure loads, all load cases. Now what it will do, it will cause few, it might cause failures. Okay, so let me write those failures here. It might cause bending failure. Okay, we call it as flexure failure. This load can cause the shear failure of the foundation. Okay, now it also might cause what we call it as failure of reinforcement, right? So we have one more thing, we have punching shear failure. Okay, so because of these superstructure loads, the foundation can go all into these possible type of failures, and we have to check. Okay, we have to design our foundations such that there is no failure due to bending or shear or punching shear or failure due to the reinforcement. Okay, so we need to do some check on all of these so that they are within the permissible limits. Okay, or they are less than the bearing capacity of the foundation itself. Okay, so I can write here. So how do we do all of these checks? We do this in using ultimate design method. Okay, ultimate design method is what we do. For example, we have a superstructure load. Okay, for example, let us say this load is P. Okay, so what we do, we multiply the P with factor of safety. Okay, factor of safety. Okay, so we get what, we get a factored load. Okay, and this factored load we also call it as design load. This load is more than the actual load. Okay, since it is more, we design our foundation based on the factored load which is more than the actual, so our foundation will be safe. Okay, now let me discuss these failures, okay, a little bit. Now the bending failure is what? For example, this is our foundation, okay, and this is our load, okay, this is our superstructure load, and it will cause, you know what, it will induce movements, right? Bending moment, right? Bending moment, okay. So we have to check the bending moment is not, it should not be too much that it will cause a failure of the foundation, okay. So how we do the check? We do the check in the ultimate design method, and also the, we have the shear failure. So the load, it will induce shear forces, right? It will induce shear force in the foundation, and we have to make sure, we have to check that our foundation has more shear force, bearing capacity, so that there will be no failure of the foundation due to the shear, okay. And we also do that in the ultimate design method, okay. Then we have punching. The punching means, this is our superstructure, right? Superstructure. Now if the shear strength of the foundation is less, okay, less than the, the shear induced by the superstructure, so what it will do, it will cause the failure of the foundation, and it will, punch inside the foundation, okay. So we call this as punching failure, okay. It happens because the shear strength of the foundation is less, okay. So we have to do the check to avoid the punching shear, okay. And also the fairing, the reinforcement, we have to make sure the development length is enough, okay. Development length is what? It is the length, these the overlapping lengths, okay, or the bond between the concrete and the, reinforcement. It should be, strong enough, because the load will try to, break these bonds, break the, the development length, okay. So we have to also make sure the, all these development lengths and the amount of this reinforcement is enough, okay, so that there is no failure in the foundation because of the superstructure loads, okay. So we have to do all these kind of checks, okay. So we do them in the ultimate design method, okay. So, and besides these, the soil related things, the settlements, the bearing capacity, the overturning, the lateral, okay, all of these, okay, and the bearing capacity, all of these, they come in the service design, okay. Service design, okay. This failure due to superstructure loads, okay, this comes under ultimate load or ultimate design method, and all other like settlement, bearing capacity, overturning, they come in the service design, okay. So I think that's it for today. If you have any doubts, you can comment, okay. So see you in the next class. Thank you.